Thank you everyone for registering for this workshop. And this workshop is going to be for Introductory Python for Chemistry. And a bit of introduction about me. I'm Vinayak. I'm a graduate student at the University of Kentucky. And I run these workshops at least once a month. And these are free workshops, and they give users some introduction to Python and how to use Python for chemistry. So this is very introductory workshop, and what we are going to cover in today's workshop is a Python primer, where we'll understand how to write a very simple code in Python. And this workshop has many users who have not used Python before or haven't even coded before. So it'll be starting at a very slow pace, and you guys can interrupt me and ask questions if you don't understand anything. And the recording will be made available on YouTube channel of Chemistry with Code. And the files associated with it will also be shared via GitHub. So first will be Python primer for about an hour, and then we'll go into Pandas. It's a way of storing data and how we can manipulate data and use that Pandas to later plot in matplotlib and seaborn. So that'll be for another hour. So do you have any questions at this point?
Yes, may I?
Yeah, sure.
Yeah, I had a question regarding that. What would be the softwares we would require while we are practicing while we are going on with this workshop? Do we need something?
So all you need for this is a Google account, and I'll be sharing links. Those are called Google Colabs, and we'll be using online thing right now. So it'll be working in your browser. You don't need any software installed. So that's what we'll be doing. So you don't need any software as long as you have a Google account. You should be good with the workshop. So yes, we are recording this workshop, and the recording will be available at least by next week on the YouTube channel of Chemistry with Code. And unfortunately, I will not give any certificates for this course, and this is a free course that I just do it out of my curiosity. And yeah, any more questions before we proceed? Okay. So we'll be having 3 Colab notebooks. I'll be sharing the links for this, and I'll show you how to work with them. And these are online notebook versions, and you need not install anything onto it. So let me get started and share a link with you. I'll tell you guys how to use it, but let me know if you guys get a link. And what you need to do is click on that. Once it is open, screen. So you will see this is a environment online, and this environment, which is Google Colab, provides a way of writing Python codes online, and you can share this with others and collaborate on writing codes. So how we are going to use this is, once you open this link, go to File and click on Save a Copy in Drive. What this will do is you will get your own copy of this notebook. This is called a notebook, and you'll get your own copy of your notebook, and whatever changes you make in that will remain. So if you make any changes in this one that you see right now, will be lost, because this is my version of the notebook, and you would not be able to make many changes that will be saved. So just go ahead, click Save a Copy in Drive, and once that is done, you should see similar notebook, but it'll be having a different name, which is called Copy of Introduction to Python and Chemistry Basics. So if everyone has reached this point, please let me know. You can give some reactions like thumbs up, or let me know in the chat that you are here at this point. If you have any difficulties, please let me know. Okay. So this is Python environment that we are going to use, and this starting part will be very slow so that everyone gets to know how to use Python. And this notebook that you see will introduce to uh, how to save data into a variable and how to manipulate that. Okay, there are some exercises here and there, and you can go along. You can go work along this notebook as I go on explaining. So there are some options here at the top, which you can explore if you want. And what we would need in this is, while going through this, is you can click on the play button, and that will run this cell. So running the cell is executing the code that is within this cell. So you can click on play, and it will try to execute the cell. And once you do that, you would see that this play button will be replaced with a number. Okay. So that will be replaced with a number, and you will be seeing 1, 2, or something. If it is not executed, the cell is not executed, you will see a blank square bracket. But once the cell is executed, you will see a number, and that number tells you that the cell is executed now. E3 now, so it's the third cell that I executed. So this is some basics on how we are going to do that. And if you can either click on this play button or press Shift Enter to run the cell. So there are two options which you can use. Click on this or Shift Enter. So everyone comfortable running a cell? Yes. Okay. So some introduction of Python and what Python does. Okay. So what we need to do in Python is somehow store some data, and then we can manipulate the data. So what we want to do now is store something in a variable. So a variable is something that can store some data for you, and we'll see what type of data a variable can store. But no number. So if you want to see a number, you need to go to some other cell and then you can see the number. If your mouse is not over the cell, you will be able to see a number when you execute it. So let me get back to this. So if you want to store something, right, you'll need a variable, and you'll be uh, calling your variable some names, but there are some restrictions on what and how you can name a variable in Python. A variable can start with a alphabet, okay, like A. Your variable can be A. You can start with some special characters like underscore. You can use underscore A, but you cannot start a variable name with something like a number, which is like 1A, or a special character like at. So only acceptable special character is this underscore. So these two are valid, and when you check for what value of A it is, and you can add a code if you want, or you can add a text. So let me add a code and say A. So A has the value of chemistry now, because that's what I stored it as. So if I want to see what underscore A is and I execute it, it should have the same thing as chemistry. But you cannot do something like this, like if you want to you want to run this code, you can just comment this out and try to run it. It'll tell you that invalid syntax. And this is because you cannot have numbers as a variable name. You cannot start your variables with a number. Same with this. Okay. Any questions on how you can have a variable name before we proceed to the other side? I know there are a lot of people who have not written a code before, so I'm trying to pace out evenly for you. Okay. Okay. So once you execute that, it'll be done. Okay. So let's go on what type of data you can store in these variables that you have created. So variables have special. Is it sensible to have capital letters or not? Yes, you can have capital letters as a name. You cannot have a space in that. So you can have something like A, as long as you want, and then is equal to chemistry. You can do this. There's no problem, but you cannot have a space in between them and do a chemistry thing. That may cause a problem. Okay. So you can have anything that you want. You can have capital letter, small letter. You can put in numbers between here. That's also fine. You can put numbers at the end. You can put numbers at the end. Even that is fine. It won't complain. But you cannot have a number at the beginning of the thing, and that'll be a problem. Okay. So this is the first thing of how you're going to how can you name a variable, and what values you can put in that variable is what we are going to discuss. It is so there's a question which says subscript numbers are allowed. So we cannot really subscript numbers in this because this is a text that you are typing. So there's no option to subscript or superscript something. So yeah, so you can even have some names like this. So you can have something underscore chemistry underscore numbers, but you cannot have you can do all of this whatever you want. So you can say something, even these things work, but don't use a space in between and don't start with number or a special character except an underscore. Okay, so moving on, what type of values can we store in this? Right now we have only chemistry stored. So what all can we store in this? So, and what are the data types called in chemistry? So first of all, we have integers where we can store an integer, and it can be something like 22, 44, all those integers can be stored here. And you can store float. Float is a different from integer. Float is a decimal value. So something like 0.74 instead of, you can have 3/4 or 1.1 or 2.2. So if you want a decimal point in between, you need to store, the type is float. Okay. You need not specify what type it is, but Python will recognize all by itself for you. Something like this in our double quotations is a string. So that's what we saved it as chemistry here. So that is a string. It's called a string or str data type. Okay. So these are single things. There's a question, is int also a float? No, those two are different data types, and integer is not a float. Okay. Those may look similar. If you have 22 and 22.0, it's same, but you still have a decimal point in there. So that all makes a difference. So while recognizing the type, it differentiates between a float and an integer. So this is just single values. What if you want to store multiple values? So Python even has that option, and it's called a list. And you can put multiple things into the list. The elements that you put in the list can be of same type. You can put all integers, you can put all floats, you can put all strings. Also, you can put something like a mixture of everything. It doesn't matter what is there in this in the list, but you can have multiple instances of things put into that. So, but if you put something into a list and you want to know what you want to associate, some way of identifying what it is, right? So you just have it at first position is 22, second position is 3/4, third position is chemistry. What if you want to know what 22 means? So in that case, you can use a type called dictionary. And in a dictionary, you associate a keyword with it. So you say int and 22. And you say, okay, this 3/4 is, I'm going to call it with float. And this is a type of association which you do. And you say, where there's chemistry, it is a str. And where there's a list, there's this list that is provided. So this is another way of saying what these type of things they are stored in. So you can have some sort of keywords put in so that you can associate them. This may sound confusing, but as we proceed, you will see how it becomes easier to access some things like this. And there's another type called tuple. And what tuple does is something similar to a list, but you need to see the difference in the brackets here. Like these are square brackets and these are like common brackets. So once you change this thing, there are some changes that occur, but I'll explain what happens, what is the difference between a list and a tuple later on. But there's this data type which is called tuple, which looks very similar to a list. And once you store something, if you want to see what type of object is stored in that, so you can just use this word type and put a common bracket and see what you want to do. So if I say I want to see what data type is stored in _int, it's int. So let me give you another example. So if I say what type is, if you remember this, we have chemistry stored in A. So I want to see what type of value is stored in A. So by default, it should be a string. So it should tell me it's str. Okay. So this is a way of using type. So type tells you what type of value a variable has in it. So you assign something like this, right? So you assigned chemistry to _str. Over here, we said chemistry1 is equal to 12. So what type of value is stored in something is what we are trying to understand here. You can store multiple type of values, right? You can store integer, you can store float, and all of this. So if you want to know what value is there in chemistry1, you'll see it is a string. Why is it a string? You'll ask me that it's 12 and 12 is a number. It can be integer, but the thing is, as once you include these double quotations, it becomes a string. Anything within double quotation becomes a string. And if I would remove this, now it is an integer. So if I check that, it should be int. So if you want to change it to something else, if I put .0, 12.0, and then now it should tell me that it is a float. Right? Now it's a float. Any questions on this? Don't if you have questions on dictionary and tuples, you'll understand it more when we proceed. Other than that, do you have any questions? So a question is basically a tuple is a list, but you cannot change once you make it. A list you can edit. Yeah, that's right. I'll go into that details later on as we proceed. But any questions on types of data types in this? So a question is, why in dictionary int also have double quotation? Okay. A dictionary is what a dictionary has these brackets at the start and at the end. And let me just explain it here. Okay. So let me add a code. So let A be a dictionary. And if I want to create a dictionary, you need to put these brackets. Okay. And then within this brackets, you are going to have some keywords associated with it. So you can just say name is, I'll just put in my name as Vinayak, right? And I can put it in what is my major, and it'll be like chemistry, right? And what you're doing here is this thing that you see in the first is a way of associating what my name is. So if you want to, yeah, let's like proceeding into this, but any other questions? Okay, so let me just dwell into that, what we can do with dictionary and elementary. So there's a question, could you please suggest some elementary text which would help us to understand the fundamental syntax of Python codes? So if you go through this notebook multiple times, you will definitely be able to understand the syntax of the codes once you go through it. So, okay. So let me get back to the dictionaries, okay? So if you have a dictionary like this, and all we are doing with this variable is trying to store some data that we have, okay? And once I execute this, now, whatever, there should be a comma here. So what I'm all doing is putting some form of data into my variable. And if I want to access the data now, that's what we are going to do. So initially we had something like integer gave us that integer that was stored, which was 22, right? And if I did str, it gave me the string because there was only one thing that was stored in it. But over here, we can see there are multiple things that are stored. So how do we access all of those? So the way to do that is by something called subscripting. And subscripting is you just need to put a bracket in there and say what you are looking for. Okay. So let's do with a list first. So if you have a list, this is a list that we had, which was 22, 3, 4th, and chemistry. And if you want to access 22 from this list, what you would be doing is you will be something called subscripting, and the index for the first element is 0 in a list. So this will be 0, this will be 1, this will be 2. So if you say list of _0, you'll be getting the first element of the list, right? If you say list subscript it with 1, you'll see that the first the list is this thing, right? 0.75. So as long as you keep on changing this, you can get those elements that you want from a from a list that you have. So that's the way of accessing something from a list. You can do the same thing for a tuple. And with a tuple, you can do list of 0. But if you want to do something from a dictionary, instead of having that index of 0, 1, instead of having the first element as 0, the second element as 1, third element as 2, what we instead do is give them some words, some names itself. So if I say int, it'll give me this value. If I say str, it'll give me the chemistry. If I say list, it should give me this. So instead of calling it by numbers, we would be calling it by keywords now. So as you see here, once we put in float, we get the float value. So if I would say list, I would get the list itself. So this is how we are going to access those values that are stored in a list. So any questions on this, or is it too confusing? So there's a question. List is kind of array then. Yes, a list is kind of one-dimensional array. So it is 0, 1, 2, and so on. Too confusing. Yeah, it'll be at the start you'll find it too confusing because if you haven't written any code, but as we go progress along it, you'll see that it'll become easier and easier. But this is like I'm just telling you things and you're not able to comprehend it. But once we go with the code, you'll see, okay, this is how it works and this is what is done. So please stay along and see how it goes. And if you have any questions, you can always ask me. So I have a name error, I have a name error. So name error occurs if you do not execute the cell or the name is not present. So if I call something here B, I should see error in that. So name B is not defined because I've not defined B anywhere in this. So you would need to execute a cell where you have used that instance before. So before going, and there's another question which is asking what is the difference between a list and a dictionary? So the difference between a list and a dictionary is the way we can access those elements. So if you want 22 from a list, it will be by index. So the index for this is 0. The first element will be index 0. The second element will be index 1. The third element will be index 2, and so on. So the index would start with 0. But if you don't know the index of that, it's very difficult to identify how we are going to get chemistry from this list. But if you do a dictionary and save the values as a dictionary, you have a way of getting chemistry just because you know it's associated with the keyword that is str. So instead of using integers like 0, 1, 2 to access it, we'll be using keywords to access it. We'll be using like a string to access it. And that makes life easier because you have something associated with it instead of zeros, ones, and twos. So that's where dictionary is a more organized way of calling things. And list is just putting things into a small array that you have. I hope that gives you some distinction between a list and a dictionary. So dictionary and a tuple. Tuple and tuple or tuple is same as a list, and that is the same thing that you see. But the difference between list and a dictionary is again how you save it. Instead of calling it by index, you now have some sort of keyword which you can associate with it. And that's what we are going to use to get values out of it. I hope that gives you some idea. But the difference between a tuple and a list is what I think we'll be discussing below. And I'll come to that once we reach that cell. So if you want to access items from here, this is how you are going to access it. So you can access from, if you want a list from a dictionary, you can access that. And if you want a float from it, from a dictionary, you would say float here. And that would give you the float value, which is present. So a dictionary can contain So a dictionary, a list can contain a list within itself. A dictionary can contain a dictionary within itself. So if I have if I make a list and say 22, 33, and then I can put in another thing, which is 23, something like this. So now it is a list of a list. So if you're trying to, let me try to get, so 22 is the first element, 33 is the second element, and this list itself is the third element. So the index for this would be B of 2 because the index starts with 0. So 0, 1, and 2. So this would give me a list now. And if I want 45 from here, I would need to again subscript this because this is a list again. And if I subscript it, 1, you'll get 45. So you can do the same thing with a dictionary. We can have a dictionary within a dictionary, and a list within a list, a tuple within a tuple, and everything. Can we store a dictionary in a list? Yeah, of course you can do that. So if you want a dictionary in this, so you can put a dictionary here. And for dictionary, you need brackets like this. And this is say first. So this is the first element. And then you say, I have a second element. And this is how you would save it as this. And now, what if you want to do access that element again, you will see it's a dictionary. And instead of doing zeros and ones, what I would now do is I will say second. And it would give me 45. So this is how you can put data types within a data type, but these are only valid for list, dictionary, and tuple. You cannot put an integer in a string. It'll be a string for you. So you can put multiple data types in a list. You can put a list in a list. Okay, so there's another question which says, what if we use a negative index? So let me do that with a negative index. So I was telling you it is 0 for 22, 1 for 33, and 2 for this. So what if you use a negative index? So negative index starts counting it from the back. So the first element, the last element will be -1. One before that will be -2, and one before that will be -3. So if I do -1, it should give me the last element. If I do -2, it should give me the second last element. So if you give negative indices, it's going to start from backwards, and the negative indices will start from -1, not -0. There's nothing from -0, but yeah. So this would be same as doing B of 1. So B of 1 is 0, 1. And if you go with a negative index, so -1, -2. Any more questions on this? So if you get this to some extent, you'll be very good in understanding Python. So these are very, very basic things of how things are stored in Python, and everything is storing in Python. So, okay. So if you guys don't have any questions, let's go ahead. So this is how you're going to access it. It's called subscripting, and you put a square bracket and put in the values, what you need. So if it is a list or a tuple, it'll be numbers or the index positions. So 0, 1, 2. If it is a dictionary, it'll be the keyword that is associated with that value that you want. So in case you can have float, you can have something like str, you can have list, and get those ones. So coming to the difference between a list and a tuple. So in a list, you can update the elements. So if I run this, you see that the list that we had earlier had 22, 3/4, which is 0.75, and then chemistry. So if I say list 0, so list 0 should give me the first element. So the first element is now set to 25. So you see that it is now set to 25. So you can change things which are stored in a list. But if you do that with a tuple, it'll complain and say that tuple does not support list assignment. So that is a difference between the list and the tuple. In a tuple, you cannot change the values that you have stored. But in a list, at any point, you can just go ahead and say, I want to change this value, and change the value. So if I make list 1 as 25, I could do that. And now it's 25, 25, and chemistry. So any questions on this? What is the difference between a list and a tuple? They are called something as mutable and immutable. That's some terminology there, but a list you can change things. In a tuple, you cannot change things once you create it. Any questions on this? No questions. So this is something else that you can do, is you can convert from one data type to other data type. Like if you have a string, you can if you have a float, you can convert it to a string, and if you have a string, you can convert it into float. Someone wants the link. I think this is the link. And make sure you copy it, make a copy of it, and save it in a drive so that changes are updated. So over here, we'll see how to change things from one data type to other data type. So initially, if you remember, float was this number 0.75. And if you do a type of it, you'll get a float, right? So because it's a float type. But if you want to convert that into a string, what you will do is str of float. It'll give you a string of float. So this is a way of converting between data types. If you have a string you want to convert into a float, you can convert it. And if you have a float and if you want to convert into a string, you can do it. This is only valid for numbers. So I can show you what I mean by this. So float is this, but if I do float is that, and now if I do string str and I do float, I'll see that it is now put in those quotation marks. So as once you see those quotation marks, it means that it's a string data type now. So this is way of converting between strings, but this won't be possible for all types, but there are only some types in which you can convert. If it is a string to a float to a string. And if you want to convert this back to float, you can do float. And this should give me a value something like this. You see, there's no quotation mark now. So that's converting between those. Any questions here? So this is the last thing that we'll discuss, and then we'll give you some time for hands-on practice. So now there's a way of comparing things now. So you can do operators. So operators, we used equal operator where we assign value to a variable. There's now a comparison operator. If you use two equals, it means whether something is equal to something or not. And you can use greater, greater than or equal to, lesser than or equal to, and not equal to has this symbol, which is exclamation mark and equals. You can use logical operators like and or not, and you can add things, subtract things, divide, modulo, which gives the remainder of something, and power operator and increment operator. So if you execute this cell, you'll see that see the values of it. So if is 3 greater than 4, it says it's false. And this is comparison. 3 equal to 4 is false. 3 not equal to 4, it says it's true. And this is the modulo operator, 6 ampersand 4. So it gives the remainder when a number is divided by the other. So when you divide 6 by 4, the remainder is 2. So that is what you get over here. And last is the power operator, which is 2 raised to 5, and 2 raised to 5 is 32. Any questions here? Okay, so now we'll get into coding and some hands-on exercise for you guys. So if you can execute a code, just type a code here and execute it. And the exercise has a couple of questions, and you can try going through that again. This workshop will be recorded, and the recording will be made available on YouTube channel of Chemistry with Code, so you can get a recording for this. So the first assignment over here is to assign x equals 12 and then increase the value by 32. So first assign x is equal to 12 and then increase the value by 32. Just add 32 to it and just see what value you get. So essentially you should be getting 44, right? So see how you're going to do that. Assign x is equal to 12. First is x equal to 12. And then you are going to add 32 to x. So we need something here. And you can just say x. It'll just print out the value of x, but you need to do that something so that the value of x is increased by 32. And we have operations here. So you can do whatever you want so that the value of it is increased by 32. Right now, if I do x, it should give me 12, but I want this value to be 44. And don't just type in x is equal to 44. There's that. Anyone who's going to try this? What is that something that you are going to do? Now we want to store the value of x as 44. So yeah, there are a couple of answers here. Yeah. So one of them is x is equal to x plus 32. Right? This is the simplest thing. You need to add 32 to x and save it into the same variable x. And once we do that, we should get. And then if you do this x, you can just type in x, or you can say print x. The more conventional one is print x. Say 44. Right? So any questions on this? This is very simple code of incrementing it. And the type of thing that we stored was an integer. And then, yeah. Okay, so this is very simple code. Now let's just get a bit complicated and do more of chemistry now, which is gas equation. So PV is equal to nRT is the gas equation, and you are given some of the values and you are asked to find the pressure. So try assigning those variables to some values. So you can say n is what 1.222 and v equals 1.628. So here you'll be only assigning the number. You cannot assign units here. In Python, there's no way of getting units. So 220, yeah, thanks. So you'll be doing this and try to find the P from here, right? So did anyone get the value for P? So you save these values first and then do those calculations. Okay, so it should be 16.8, I think. So many of you guys are getting that. So PV and R is just put in those values there, 0.8 Use that. Where's that? And C is 73. And then P, so P equals, what should be P? P is equal to N times R times T. And what you need to remember here is division. You would want the whole thing to be divided by V. Just remember this, and then if you do that and say prevent pressure, then you put a comma and then say, I think they should give us. There you go. There's a question, why did you use the slash and not percent? So ampersand. So ampersand gives us modulo, which is something like this. So if you divide 6 by 3, 6 by 3, it is exactly divisible. So the number is 2. And the remainder should be 0. So if you check for remainder, and it will give us 0 here. So this ampersand is used for getting the remainder when something is divided. And this works for integers only and not for float. It may give, let me check for this. Okay. So P equals Y, you put there's a question which says P equals Y, you put a space. Python is not very particular about space, and you can put space everywhere, wherever you want. It just makes the code easier to view. And instead of saying everything like this, where it's too complicated to see what is happening, right? It's too compact. You can give some space everywhere. So Python is okay with spaces. You can give space as much as you want. So if I put multiple spaces here, and then this won't be a problem. Okay. So any questions on this? I hope you guys are getting comfortable now with storing values and getting things, but do you still have any questions from? Okay. So there is this, will not, I think we should go into this. So you don't declare, so there's a question which says, so you don't need to declare a variable before using it. Declare a variable, no. If people are accustomed to using C or C++, wherein you need to say, okay, this is the variable that I'm going to use, so int of n, and then you call n equal to this. This is not what Python wants. Python is very friendly with you and says that you can put whatever you want in a variable and add it in runtime. The advantage of that is here T was 273. I can now set it T2 as chemistry. So it won't complain about that, because earlier it stored a integer type, now it's storing a string type, and Python is perfectly fine with that. And there's another question which asks, is Python case sensitive? Case sensitive, yes. So something like this, nt is different from nt. So if you say nt, so all those names are very different. So it's definitely case sensitive. So whatever you put in, it's case sensitive. Any questions? Okay, so let's proceed with what else we can do. We did some basic arithmetic here, which is addition, subtraction, and division, looking at the things. There's another question about dimension analysis, and what about if you have moles and some other values, but the Python cannot handle dimension analysis. in its native form. So you would need to have in a specific all of those dimensions in what you need. So the units of pressure is not possible to calculate, in at least in the native code. But there may be some packages which could do that for you, but in native code you cannot do that. So there's no units in this involved. If that answers your question. So let's go to selection. So selection is selecting or executing one part of the code. So based on the condition. So based on the condition, it will execute one part of the code. And the syntax is like this. So if and then a condition. And if this condition is true, what do you want the code to do? And there's another elif, which means that if this is not satisfied, you can check for the next condition, elif, and put a condition. And below that, what code you want to be executed. And this can be one line of code, multiple lines of code, it doesn't matter. And then finally there's else. So if none of these conditions are satisfied, it will do the final thing, which is else. So this is the selection which is used, and based on which condition is satisfied, it will be executing the code. So if the first condition is satisfied, the rest of the code, which is elif, the code in that or else, will never be executed. So there's only one part of the code which will be executed here. Either the first one, print true, or either the print neither true nor false, or false. So multiple of those will never be executed in selection. So that's how selection goes. And in this case, is phi greater than 1 is 2. So the first thing is executed. So you get 2. If I change this value and say -1 is greater than this, and let me put here 6. So now the first condition is false, -1 is not greater than 1. But the second condition, which is phi is less than 6, is true. So you'll see neither true nor false executed. And even if I change this condition, you'll see the last part will be executed, which is false. So it decides which part of the code you want to execute, and we'll be using some of this in the exercise that we have for this. Okay. So any questions on selection and how this is? So there'll be if, these are keywords that you need to use. So if, elif, if you have another condition, or else. There's no need for you to include else or elif. You can just have if and some condition. So that is also fine. So you can have if, you can have if else, or you can have if, elif. You can have multiple elif, and then leave it. So there's no need to have an else. It's not mandatory to have else. So there's one question: what if we have more than a value of temperature? So if you have multiple values of temperature, you can, as Valeria said, you can use a list and then do it for each one of those. And yeah, so you can use something like that, t equal to this. Also, let me just copy paste the code here. So if you do this, your p will be just one value, event p. So p will just be a single value, but if you need multiple values, you would need to do this as multiple ways to do it. So you need to have it as a list and then do it. So this is just one value. So the second value will be this. So you get a different value for that. So for that, you need to initialize this as a list. So this is initialization. And then you say the first element will be the first element of this. And then you do the second element is the second element of that. Now it should be a, let me just have it 0 somewhere, because you have two of those. Let me make it 0 and 0. So now you get two values. There are other ways of doing it, and there are for loops and other things. We'll discuss. This is the most simple way of doing it, but there are more sophisticated and easier way to do this too. There are multiple values. So yeah. So any questions on selection? So if there are no selections, this is where loops come in, and loops is exactly what we can do with this. So we have two values to loop over, so we could do the same thing in loops now. So that's where loops come in handy, and this is what it is. So you can loop over a list and say for each of those lists, let me just get this out. So if I have this code here from list, so you see, I can loop over the list that we initially created. If you remember, we had 22 and then we changed it to 25, 25 chemistry. So if you loop over this, that's how you are going to do it. And let's do the temperature one here. So T had those values, if you remember, right? And let me get this formula too for getting the list. And let's put that formula here. So for I, so I is an instance. So when you loop over something, this is the looping, what you're looping over. And each loop will give you one element. So for the first time, your element is 25 in the list that we had before. The second time it is again 25. So I would give you all those temperatures. So let me just show you what I mean by that is prevent temperature, and if I put I, you can put anywhere value here. Let me put temperature T, small t, and if I do this, it'll say the first temperature is this, the second temperature is that. So you are looping over it, so you're getting one value at a time and then doing something. So what I can now do is use that, and instead of T of 0, I can put T and say pressure is this. Pressure is this. Right? Is that. So if I do this, I'll say for this, that pressure is this, for this, the pressure is that. So this is how we use looping and do all those things that we could do for multiple values when we have multiple values. And that corresponds to a list. You can even do this for a dictionary. You can do it for a tuple. And all of that is discussed in this block. So if you run this block, you'll see how it's done for a list. So if you do it for a list, this is what you get. If you want to do it a number of times, like 3 times or 4 times, so you could use something like length of something. So a range gives you a number and these many number of times. So the first number will be 0 always. It indexes with 0, 1, 2, and so on. And you can also count things at the same time while looping. If you use enumerate and then pass in the thing that you want to loop over. So I would be the index and j would be the element itself. So this says 0 is 25, 1 is 25, 2 is chemistry. So it gives you the index as well as the value from the list that you have. And if you do that with a dictionary, you can do with keys. So those keywords, if you loop over the keywords, you'll get the key, and dictionary of those keywords should give you the value. So you'll get something like this. So these are the keys of the dictionary. If you remember, we had int, float, str, and list. And these are the corresponding values that were stored in them. Any questions on this looping? There are some more examples later on in the exercise, I think would help you with looping. Okay. So if there are no questions, let's see. This is the for loop where you know how many times you want to do it, and then there's a while loop where you try to satisfy a condition. When this condition is satisfied, you exit the loop. There is no way of determining how many times you would go unless you know what you're doing, but you have a way of seeing what happens. So if you run this, it's going to generate a sentence for you with less than six words. So chemistry 1, 2, 3, 4, 5. So this is what it generated: chemistry exclamation and machine discovery, and so on. So there's something called import, and I'll discuss what it does later at the end of this. But you can do something like this and use a while loop, which is based on this condition. So as long as this condition is not condition is satisfied, it is going to execute it. When the condition turns false, it will not execute it. It will stop the execution. So you see, if there are six of them, and when the length is 6, so it'll be 6 less than 6 is false. So that's when it exits and gives us this. So there are functions and other things. I think this part is just for you to look at if you are interested in. There are classes and other things. But what you'll be using most is this thing, which is called method. So if you have chemistry in uppercase, you can do it in lowercase by using this method called lower. So it'll lower it for you. And if you want to find the methods associated with this chemistry, so you can say dir of the chemistry of a variable, let's say a. I don't know what a was, but let's see. So a is, okay, a is a dictionary. So let's go with the string itself. So if I want to do dir of chemistry, a string, you can see a list of them being put out here, right? So you can check for all of this. So you can check whether the thing that you have is decimal or is ASCII. So let me try one of these. So ASCII. Let me see whether I can do it ASCII. What is it? Maybe split starts with. Okay. Let me use starts with. So I have a variable name is my name is Nayak, and I want to check whether this starts with, so name dot starts with V. So it will say true. It does start with V. So if I want to see whether it starts with C, it says no, it does not start with C. Some of these you can do title case. So if you say name dot title, it'll give me a title case, but title case you won't see the difference. But I'll say upper. If I do this, all of them will be converted into capital letters. So all of these methods you can explore and see whether it is a digit or not. So you can apply these methods, and that is what we are going to do in this exercise. And we are going to write a small Python code here, which tells whether these things are acids or not. So this is the thing that we have, and identify them as an acid or not. So if someone, let's say, compound is HCl, okay. So print whether it's an acid or not. So we want to say, we want to print somehow. So at first, what we are going to do is check whether an acid. And you need to write some code here how you're going to check whether an acid, and then you're going to print the result, whether it's acid or not. So you can use some of these things that we discussed, like upper starts with, and some of these probably you'll be using starts with, and you can save compound dot starts with v, and it says true false based on that. So something like this you could be used in getting to this solution here. So if anyone has tried it out, please let me know. You can just share the code in the chat. And if you have any questions on what we have discussed so far, please let me know. And these are something called methods, and those are used with dot something. Okay. Unlike these ones, these are functions where you call print, put something inside them, and this is like dot something. There's some distinction between them. Distinction. So if you read this, you'll understand. But use dir to get to know what is present in that. We'll do like 5 minutes on this, and that you'll just do one exercise in this. You can do the remaining one yourself, and we'll probably finish the first session by then. Like a couple of more minutes on this. So if you have any questions, please ask me. Was anyone able to get the first, write a code for the first one to identify acid or not? So if you want to, functions are different. So functions are these ones like print and other things are functions, and we call this methods. So methods operate on objects. So you can on chemistry or string, something like this. So dot lower is a method, and if you want to see what methods are available, you are going to type in dir and pass in that variable that you have. So if I pass in name here, so name is this thing that I saved here, right? So if I want to see name, I get all of this here. So these are the methods available. I can count how many characters are present. I can see whether whether this thing ends with something. I can get the index. I can get whether it's alphanumeric or not, and all of these. There's one thing called HCl.acid. Acid is not defined in the string over here. So basically what I'll tell you what the hint is, right? So if you look at this pattern here, HCl, NaOH, KCl, H2SO4, and all of them, the acids are HCl. HCl is an acid. H2SO4 is an acid. HNO3 is an acid. So all of them, you see, start with a H, right? So HCl, H2SO4, HNO3, HCO2H. So all of them start with H. So that's where you're going to see if something is going to start with H or not. And if something starts with H, you're going to say it's an acid. If it does not start with an H, it's a base. Right? So if someone wants that file, let me just copy paste it. So this is the link if someone is late. Okay. So let me try it here. So what you're going to do is if condition, right? So let's first do this compound dot. So you want to check whether it starts with H or not. So it says 2, right? What you can do is now put in a condition. If the compound name starts with this is the condition. You will say print acid. So if compound does not start, we also want to say it's not an acid. So we use else and then say print not acid. So if we execute this over here, it'll say acid. Right? So now let me change compound from HCl to NaOH, and it should say not an acid. So this is a true or false. It returns whether it's true or false, and that's what we need for condition. And if something, print this, else print that. So there's another yeah. Could we write compound of 0 equals this? Yeah, this is a very nice thing too. So if you look for compound D, so if you look at compound, all of them are strings. So if you do compound of 0, it should give you n in this case, right? So if I put HCl, yeah. So now compound of 0 is the first character that you see. So you could use even this. You could say compound of 0 equals H. And instead of compound starts with, you can even use this condition. So if compound this, you can use the same condition here and then say, and then it will say now, I missed a colon. So don't forget there's a colon here. Okay. So it's an acid. So you can even use that part. So a string again, this is a good thing. A string again can be accessed by each character. And if you do 0, 1, 2, 3, it'll loop over each of those characters. Can we sort? There's another question which asks, how can we sort all compounds to acids and bases? So you can create a list of acid, a list of base, and keep on adding them. It'll be a bit complicated. I don't think that I would like to discuss it right now, but you can create it like a list and say acid or not. So this is just to answer that question which was there, and you can make a list of all of these, right? You can say compounds are these, but you need to have let me just choose 4 of those. Well, if you're not able to understand what I'm doing right now, it's okay. This was just to answer one of the question that was asked, how to classify things into acids and bases. And you can do something like this and say acids is an empty list, and then say bases, base is an empty list. And now we are going to add things onto it. And we can use the same thing, right? We can use the same condition, which is acids and bases, like this. But now if it is an acid, we need to add it to this acids list. So we say acids dot append. And else you do base dot append. So this is a way of adding things to a list compound. But now we need to loop over this in each of the compounds. So for compound in compounds. So if I do this, so now I'm looping again. Please remember that there should be a thing, there should be a tab or something between these loops to execute it. You can't write them in a line, but this thing does it for you. And then if you print acids, print base, it should print both of those for you. So this is a way of adding things onto it, but you can be more creative and do whatever you want with those. But there's something called append. So again, if you want to see what, again, this is a method. This is a good thing to look at. And you want to see what methods are present for something. So you can say dir of assets. So you can see, okay, There's append, there's clear, there's copy, there's count, there's extend, there's index, there's remove, there's sort, reverse. So you can apply all these operations for this, and you can find out some interesting things about what is stored in them. So over here, I use this one, which is append, and that is what gives us this. So if you uh, want to know how things are done, you can just look at this. This is how Python would work. And if you don't know what is there in this, you just type in some of these commands like dir assets. There's another command which is called help, and you can pass in whatever you want in them, and it'll give you some help about it. So this is argument, the constructor creates a new list. So this is help about the object, what you can do and what it does. So if you see count, return number of occurrences of a value, copy, return a shallow copy, clear, remove all items from a list, append object to the end of the list. So these are the things that you can look for. And this is with any code that is available in Python. This is how you're going to try to understand it. So these are the very basics that you need to understand. And like help, you can use help and pass in an object and see what you have in this. So finally, I'll just conclude with this part, which is importing. We used some libraries on top, which is random, and the way we import them is we are calling in some definitions from other libraries. We'll be doing this a lot in the next one, which is pandas. And from random, we are going to import something. So we'll say import random. And if we want to use this one, which is a built-in method in random, you're going to call random. But there's another way of doing it. You can say from random, import random, and then use just random. And you can just read through this. I would not stress too much on this right now, but can you share your code with the list? Uh, there's a question of code with the list. I can share this thing if you guys want. And this is the code with the list. So you can do this multiple things for you. Okay, so I think we'll take a 5-minute break right now, so that this is some heavy content that we discuss right now, because there are people who have never done coding before, and try to assimilate these things and try to do a bit of stretching. So we'll take a 5-minute break now, and we'll be back in 5 more minutes. So if you have any questions, you can just type in the chat, and uh, when I come back, I'll just look at them and try to answer those. Please, could you show the last script? This is available, that one of the molecules you classified. Do you mean this one? I think I copy pasted that thing in the chat. So you should be able to see that in the chat, this part of the code. So I'll just leave you guys over here with this code. And if you have any questions, please type in your questions. I'll try to answer, and we'll just take a 5-minute break. Now it's like 4-minute break now. So relax a bit, and I'll see you in like 4 minutes. Okay, so there's a question which asks, could you review how to obtain or create the DIR chemistry? We'll discuss it in like a couple of minutes. So, could you review how to obtain or create the DIR chemistry? So DIR is to get all the methods that are associated with a variable. So chemistry, I did not create a variable in that case. Where was it? For this, I did not create a variable. I just passed in chemistry itself. So you can even do that if you want. You can just pass in a list and say what methods are available for a list. This is an empty list, so it'll give you what is present. So there's no need of creating a variable and then finding out what methods are associated. But no, you always end up with storing data in a variable, and then you need to know what you can do with that variable. So you just pass in whatever you want inside that. I mean, whatever type of object you want. So you can pass in chemistry within this and see what things are available for chemistry. And the same with the name. So name and chemistry of same data types. So these things that you see are irrespective of what is stored in the variable. As long as they have the same data type, you'll have the same methods available. So both of them are string, so you'll always see string. Okay, so let's move on and we'll get started with another one, which is pandas. And this is the link to pandas notebook. Okay. So can everyone see my screen? Yes. Okay. So I have shared the link. So we'll do the same thing with this link again. Go to file, save a copy in Drive so that you have your own copy and the changes that you make in them is saved on your Drive. So we now have a copy of it. So at first we'll install this package called Mendeley. So we'll run this cell first. Try running this cell and it'll try to install a package. So you can install many packages in this way when you do that. So once you install it, you'll see restart runtime. So you just click on restart runtime. You'll see that you are about to start runtime. So you say yes. So once that is done, Mendeley is installed. So we'll be using that package to explore pandas and with more application in chemistry. So if everyone is here at this point where they have restarted the runtime, please let me know so that we can proceed. The first step would be run the cell and then click on restart runtime, and it'll give you something like restart runtime like this, and then say yes. So a few yeses. So let's get started with what Pandas data frame does.
Excuse me,
So
sir, sorry to interrupt you.
yeah,
Yeah, so after clicking on restarting the runtime, can you please show me the terminal? That is there any change in the terminal or it will remain as it is?
it will remain as it is. So you don't need to change anything. When you click on restart runtime, you just say yes. So it will say restarting, initializing, and once it is ready, it will be ready. And to check whether it's installed or not, click on this run this cell. So if you do not get any error on running the first cell, it means that everything is done perfectly fine. So in the previous thing, we saw lists, how we can store multiple values, right? So if you're doing any experiment, you'll have X and Y columns. If you're doing absorption or anything, you'll have X and Y, and you would want to save them in some nice format that you want. So you could save them as a list, but it becomes too complicated of adding things and reading things. Uh, so that is where we are going to use pandas. And Pandas creates a Excel-like thing, right? It creates a Excel-like table where you have columns and where you have rows. And now it's very easy to get whatever we want. Suppose we want X value, so just get the X column. It'll get you the X column. Get in a particular row that you are interested in. You can get that row. So that's a table-like format that is available in Pandas. So it's very easy to work with more scientific data than using the most generic types like list or dictionaries and other things. So there's a question, why do we need Mendeleev package? So this Mendeleev package that is installed is just to get data, and we are going to use atom data, the periodic table data, for understanding how we are going to use pandas. And that's more of chemistry application. So that's why I chose to use Mendeleev. So there's nothing special about Mendeleev, but we just need data for it. So if you run this cell, once you are done with the first part, once you run this, what we are doing here is this is an import statement. We are importing something, and we are importing the definition of fetch table. And you need not worry about what is done here, but we are getting element data from the periodic table, and we are saving it as a p table. And if you look at what the p table is, what type the p table is, oops, yeah. So it should tell you, oops, where did that go? So it's a data frame object. So this is what we are going to look at, and how we are going to use that object. So the things that we learned, like dir, help, and other things, all of them are applicable here. That's why I stressed on them a lot. And what you can see what it does, and there are some examples of using it if you type in help. So you'll see some examples of how things are done with this particular object. Okay, but let's go into what we can do. So we now have a table, and table in pandas, a data frame in pandas is a nice Excel-like sheet where you have rows and columns, and we'll see how it looks like. So this is a method called head, and if you want to see what methods are available, just do dir and p table. You'll get to know all the methods that are available, and head is one of them. So these are methods that are available. It's a very long list that we see here. So back to this. So we want to see what is present. So if you say head, it'll give us the first five entries in that table. So this is a nice table, as you can see. and their annotations, some atomic number, atomic radii, atomic volume, the block which it belongs to, and boiling point, and so on. So this is a nice way of representing, and each one of those would be integers, as we discussed before. This is an integer, 1 is an integer, 25 is a float, s is a string. So all these basic data types are in there, but they are now embedded in this nice table that you see. And it's now very easy to get those values that we want from here, and we'll see how we do that with this. So head would give us this, and these are the columns. Some notations about this. These are columns, these are rows, right? And this is an index which tells you a way to get the elements just as a list. Had an index of 0, 1, 2. By default they are 0, 1, and so on, but you can change the index to whatever we want. But we'll see how to do that later on as we proceed. So these are columns and these are rows, and there's an index associated with it. That's all we would need to know about it. So yeah, so the question, there are a couple of questions: how to know the packages available in Python that do for chemistry, and you just need to Google search them, and just Google search whatever you want with Python package. You may find it, and if you want to install it, you can use something like this: pip install that package that you want. The instructions will be there on the code, and then you can run the code in this. So if you want to use Colab for that, but you can have a local installation of some package on your PC and then do it. But that depends on how you want to do it. So there's another question: how did you get to form that table? The formation of table is from Mendeleev. That's what we are using. So Mendeleev is what we are using to get the data. So there's data in this. So we use this fetch table of elements. So that gives us the table all by itself. So that is why we are using Mendeleev for this. Mendeleev is to just get us the data and form that table. You can create a table on your own, and we'll see how we can do that as we proceed. But I needed some data for you guys to understand how to work with it instead of creating from scratch. Hope that answers your questions. So if you do head, you'll see a nice thing of columns and rows. And now if you do dot columns, you will see how many columns there are. So these are the columns that are available. So dot columns is another method. If you do dir, then p table, you may have seen columns somewhere here. Where is it? Let's see. COL. See, there's columns, there's combined. So I used one which is columns. So columns gives us the list of columns. So these are the columns. We have van der Waals radii, we have discoveries, the year it was discovered, metallic radius, all CAS number, and all those kind of things. So this is a data frame. This contains multiple columns, and each of these columns are called a series of data. So you can get a series from getting something like this. So let's say you wanted a column with atomic radius, right? So if you do p table would give you the entire table, right? So there are 118 rows and 70 columns in this. The entire table has those many. But what if you just need atomic number? So what you do is the subscripting thing, as we discussed in lists. And over here, you will put in the column name that we want. So if we want atomic number, we just say atomic number, and it'll just give us the atomic numbers now. See, this is the index that is set, and that is the atomic number that we have. So you can put in multiple things. And if you want multiple things, you'd need to pass in a list. And let me say I want atomic number, I want atomic weight. So these are all the columns that are present. So I can just pull in whatever I want from here. So let me get van der Waals radii. And if I do this, I have a nice table, but I have only the things that I requested for. So you see how easy it becomes to get the things that we need from you. And you pass in a list and then list of things that you want from this table. And you can put in any number of things that you want from you. So that is what we are going to do now. So again, we can save that as a column if you want. Where did that go? So we can do something like this. You see what is happening here, or else we can just say atomic radius, and it'll give you a list of atomic radius like this. You can save it to a variable if you want. You can save it to another thing that you want here. Like you can save it to another variable, the whole thing into another variable, and then manipulate it. So any questions until this point? So you can try it out with multiple things. You can just try changing numbers. Once you have the column names, all you would need to do is copy those column names and paste it in this list. If you want just one column, you can just paste it in that, and then needs to be a string always, and then you get that column. That's always easier to just something and get thermal conductivity. Okay. So you can get any number of columns that you need, and that's how we are going to access columns now. So we looked at how we are going to get columns from this nice table that we have. And there's some nice things about it, which is once you have the atomic radius or whatever table that you want, in this case, the atomic radii, and I have this method. If I do dir on this atomic radii, I'll find that there's a method called describe, and it gives us some statistics about this particular column. So it says count, there are 90 of those, the mean is 149, the max is 260, and minimum is 25. So it gives us statistics on the entire thing. If you want the statistics on the entire table, you can do ptable.describe, and it will give you statistics on the entire table now. And for each column, it's going to tell you, okay, atomic number has 118 counts, 118 items, and mean is this, max is this, boiling point, there are 96 of them which have boiling point, mean value is this high, minimum is this, and you get all statistics on that. So any questions on this?
So I had a question that this particular package, like the Mendeleev database, this is quite actually directed, or it is quite pointing towards the use of the periodic table. But if we want to do any other work, like other different calculations or other aspects of dealing with chemistry, so are there packages related to it?
So let me get this one clarified for you guys, that this pandas that we are working with has nothing to do with Mendeleev. So Mendeleev just got us the data that we want in the data from here, and pandas is where did it go? Okay, so pandas is this part. Okay, so the data that is within this pandas data frame comes from Mendeleev, and the operations that you see over here, ptable, columns, and other things are for pandas. Okay, not to get confused with Mendeleev. Mendeleev just gave us the data within this, but what we are doing is pandas. And regarding data, there are a lot many data sets that are available, and we can just read it into pandas. And there's no need to have a package like Mendeleev to do it. If you have a nice Excel file or CSV file with data, you can load that data into Excel, and I'll discuss how to do that later on. And you can start working with it. There's no need of installing a particular package to get a data and then work on it. Over here, this was very simple for me for this workshop, for you guys to get some data and work with. So that is why we are using Mendeley to get this data. But you can get the data from any source that you want, and there's no need of package that you need to install. And any article or publication would give you some data in a nice format, and you can just read that format as an Excel file or CSV file, any of those files that are readable by this, and you can get the data in Pandas. I hope that answers your question. Chris says, I think the confusion lies in the fact that p table is assigned from Mendeley. Yeah, so p table is assigned from Mendeley, but that is just to get this data that we have in the data frame. So just to get this data, just to clarify that. And Pandas is very different from Mendeley. Mendeley was just to get this data. Okay, so fetch table just gives us the data in the Pandas format, and that's what we need to work with Pandas. Okay. There's another question. I suppose this is helpful for surface or radial distribution of fluids. How to get 3 coordinates from the maximum? How to get 3 coordinates? I'm not quite sure what the last part of the question meant. But I think we can discuss it later. In the interest of time, I'll just proceed. But you can try to figure out how to get multiple coordinates from this, and you can just play around with it. Okay. So this thing describe is again a data frame if you look at it. So TYP type of this describe is again a data frame, and you can do all those operations that you have been doing on this data frame right now. So describe is this data frame, and you can get again do the same thing like if you want atomic radius, get the atomic radius data. So yeah, I can't see the whole table, just first and last row. Yeah, this is the restriction is because please can you show starting from a list dictionary. Sometimes you'll see some of the elements are not shown. If you just type in p table somewhere, I thought I did, but I didn't. Okay. So if you just put in a p table, periodic table here, you'll see that some of the columns are, you won't see all 118 columns here. You'll see dot dot dot, and this is just because it does not want to show all of the data for you, but you can still access all of the data. So there's another question. Please, can you show an example starting from a list of a dictionary so the contained elements will be ensured in a table using pandas? Starting from a list of a dictionary, I would say we use less of that form, where when you start with a dictionary, create a dictionary, and then do it. The easier way to populate a table is from an Excel file or CSV file. So once you have a nice data in a CSV file, you can just put it in here. But I'll definitely, if time permits, I'll definitely go over that, where you can create things from a list and dictionaries and do that. But getting it from an Excel file is the most easiest way of populating a data in a table. So yeah, let's proceed with this. And some things about this data frame are like you can see a lot of NaNs in here because there's no data available. So what we could do is, if you're doing some analysis, we can just drop these NaN values. To do so, there's another method which is called drop. Where is it? Okay, there's called drop NA, and drop NA just drops those elements which have NaN. So now you see we have 90 of those and 90 atomic mass. Earlier we had 118 of them, but only some of them had atomic masses, right? So there are 118 of these, but there are a lot of NaNs here. So the way to drop those NaNs, like you can see NaN, NaN, the way to drop them is with drop Na. So if I do p-table atomic mass drop Na, we'll be dropping those and we'll just get 90 of those. Though you see numbers going up to 94, but these are the indices of those elements, and they are not exactly 0, 1. It is not in the sequence up to 94. So drop NA helps you to drop those NaN values. Now let's look at how to change these the indices, the index that we had. So if you remember, the index started with 0, 1, and so on. But because this is a periodic table and we know that atomic symbols are unique, we could just use our atomic symbols as the periodic table index. So we say p table set index. There's a symbol column. Let me show you guys what the symbol column is. So p table symbol. So p table symbol has that symbol, right? So you see 0 is HE. 0 again is these are the indices on the left, and the right side are the symbols. So we can assign the symbols itself as the indices because we know they are unique. So that is what we are doing here with p table set index and new. So the new table now, as you see, the first table here will have H, HE, LI, BE, and so on, instead of zeros, ones, and twos that we just saw earlier. So if I say p table dot head and do this, it started with zeros, ones, and other things, but now it starts with H, HE, LI, and so on. Okay, that's how we are going to change the index of it. So any questions on this, on the index part, or dropping NAs? Okay. So if there are no questions, we'll proceed. And what is the use of these indices, right? You may ask, okay, why do we need to have them as H, HE or something? The reason is this. Getting a column was easier. We would say that the p table square bracket and atomic number gave us this column, atomic radius gave us this column. But if you want to access a row, you would need to use the index of that. So if you have some well-defined index, you can easily get those values, like with the log method. So if you use log of H, you'll get all the data for that element, for that row, which is for hydrogen. So you can say HE. It becomes easier because you know all these symbols are unique, and it's easy to relate with them. So I can say log C is for carbon, so this value is for carbon. This is all of the data that we have for column for that particular row. So we get the entire row from using this. So this is with lock, but all this is for table. And if you want to do with index, so if you don't know which element you are looking at, but you just need to know the first element in the first row of the table, you can use iloc, which is for index based, and iloc of 0 would give you the first one. If you say iloc 1, it means get me the second row of the table. You're not interested in what the row is, but you want the second row, third row, fourth row of it. So you can use iloc for that. But if you are very specific in saying, okay, I want data for this particular element, I'll get loc of C. But this is only applicable because you have your index set as C now. But if you would use this on a old table, let me show you quickly what I mean. So if you do this p table dot log of H, it will complain that the H is not there in the index, right? Because the index for the periodic table was 0, 1, 2. So the index is now 0, 1, 2. So there is no H in that. So You can't do something like that with this, but you would need to use 0 because the index for that was 0. So then you get it. So this is where setting index to whatever you want makes easier to access those rows in it. So there are a couple of questions. Do lock apply for any method? So lock method is only for periodic, a data frame. So once you have a data frame object, so once you have something like this, or even the describe thing that we had, I don't know where that is, but so as long as you have a periodic, not periodic, as long as you have a pandas data frame, you can apply the lock to get the rows. Okay. Apply for any method. And symbol has double quote, which means string, right? How can you change the index? The question is symbol has double quotes, which means string. Yes. It depends on what you have over here. So this data type for us is a string, and you can check that if you want. So if you do the index thing, let me add another one. So if you say new ptable dot index, this one. So if you do index, it'll give you a list of all of them, right? So if you take the first element now of that, will should give you h, and now you can check the type of this and then see whether you want a string or not a string. But if I would do this on the old table, which has 0, 1, and 2, you see that it's an integer, so you would need to omit those strings. So that is why over here I use plock of 0 and not 0, right? Because that is an integer that we want, so it should be this. But for lock, it is I'll say new table index of 0. It's a string, so I use a string. That clarifies it. There's another. Okay, that's it. So. Any questions on this? If not, let's go on to the next exercise, which is uh, calculating the volume of it. So assume that atoms are spheres and then calculate the volume by doing this. And just as an example, what I can show you guys is so P table of something. P table dot atomic radius. If I do this, I get the atomic radius. I can do any operation on this. I can multiply it by 2. So I can multiply it by 4. It multiplies all throughout, so you need not worry about how it is done. So you just assume that all of them are multiplied with 4. So or divided by 3, divided by 2. So it will be divided by 2. So try to do this operation and find the volume of try to calculate the volume using this formula. This is just math operation, basic arithmetic operation, but you are trying to do it on a data frame, and it's not a single value that the operation will be done on. It will be done on the entire column that you have in the data frame. So try calculating the atomic volume and see what you get. And there's also another exercise to set the column with atomic symbol as the index. I think we already did that, but you can try it again. So was anyone able to do the first one? So there is one which is yeah. So column of yeah, calculate volume is atomic radius times 3. Yeah. So it's just replacing radius with the column of p table atomic radius, and it will give you that part. If you have any ends, you can just drop them and then pass in. So what I could do is I could just copy this, paste it here, and instead of radius, what I need is p table and atomic radius. And if I want to drop any, I can drop any here itself, and then and this is the volume that we get. And because I dropped NA, it's only going to calculate on 90 of those. So you see, there are only 90. And if I don't drop any, let me see whether it's going to multiply it or not. Because so it does NA and NA and NA. Okay. So yeah, there's another question which is, can we append p table with our newly formed? Yeah. So if you want the newly formed atomic volume, make sure that the name is very different from what we have set. So let's call it p table. What we are going to do is we are going to add a column. So the way to do that is you have p table, and for creating a column, let's say calculated volume. If you just do this, or p table dot p table, put in square bracket and calculated volume, it by itself will create a table for append a column into this, and once it is done, we can just see p table. We do that. So the last column here should be calculated volume. So that is how we can append the newly formed data to old ones. So yeah, this is how we are going to do this, appending of it. So you can do multiple times calculated volume 2 or something. And as long as they are strings and you can access them, you'll still have the same thing created. So I added some weird name 2 plus E or something. So you'll see that column there. So there's a question which is the recording for this, your first 30 minutes. Yeah. The recording will be made available on the YouTube channel of Chemistry with Code. So you can have a look at the recording, and the files also will be available. Okay, so there's another question. Could we graph? Yes, that's what we are going to do in the next part of it. And that's where we are going to make graphs out of this. We are going to make plots out of whatever we want, probably atomic radius, and see how it goes from there. Okay. So you can set the column. That's something else that you can try to do. And let's go into something more interesting, which is group by. Okay, so group by is a way to get your information in groups. Like we have periodic table has a S block, P block, all of those. So what we could do is we can get those by groups, and these are usually done for categorical data where we have group information and it's not continuous. So if we do this, so P table group by, and why I choose block is because if I p table dot columns. So if you see p table dot columns, there are a lot many things in this. So if you choose, we need to choose something that is categorical, that has categories. Like atomic number is continuous 1, 2, 3, 4, 5, 6. So there's no point in doing something like that. But if you go with blocks, you have S block, P block, and there are a number of elements in those blocks. So we say there's a block column. So we say, okay, p table group by block. So we are grouping it by block, and we can get one block out of it. So over here I say block group dot get group and s. So let me show what p table and block is. So p table and block will be having s, p, and all of those. And there's something pretty nice about this. You can just use unique onto this. This is a method again, and it will show you unique things that are present in this block. So there's S, P, D, and F thing which is present. So you can get any of those blocks. Over here, I get the S block, and you see all of the S elements are grouped now. So this table only consists of S elements. So maybe I should have, okay. Just for simplicity, I'll have atomic, just for you to be sure. Was it? What was that name for? Just symbol. Okay. So if you do symbol, you will see that all of these are S elements. Also includes helium somehow. Okay, that's interesting. But yeah, so all these are S elements. You can get F if you want. All those will be F elements. So this is a cool way of getting groups, and this is applicable for you. We probably use it for categorical data, which have categories. So there's an exercise for you guys now. So I think this, yeah, this will be the somewhat last part of what we are going to do in this pandas, and you can explore rest of it on yourself. And over here, what we are going to do is group data by element, by block, and get the element with highest boiling point in P block. So you could use the max and other values to see what the element is. Try to find the element with maximum by boiling point in the P block. You could use the block thing again. So block group dot get group and P. This should give you the P block elements. Now what you need to do from here is to get the boiling point, somehow get the boiling point here, and then get the maximum of boiling point and see which element it corresponds to. At least print out the column with, print out the row with maximum value. There is a list of boiling points. You need to see the maximum out of it. So you can check what methods are available for this dir and see whether you have something to get maximum for you. Max, there's something called minimum. There's something called maximum too. So there's a method called maximum. So you could use method called maximum on this. So that's the maximum value. And which does it correspond to? So this is the maximum value of it. Question is how to get the index of the maximum value. Maybe I should have covered it next time, but yeah. So let me try to explain that. I'm sure should have been, but yeah. So let's do this boiling point. Um, boiling is this data frame for boiling, and let's add some code. So boiling is this nice thing that we have. Let me make it a data frame. So this is the boiling point, and because we use that, maybe the boiling point is this. So how we do something, how to find values is something like this. So a boiling point, you can put in a condition here. Okay. So if you put in a condition, it will get you a row where this condition is satisfied. Okay. So what you want is so one is this thing, right? So if you do boiling, if you do a data frame and then pass in a string the row of the column, it will give you that. But if you do something like this, boiling point dot boiling equals boiling dot max. Yeah. If you do this, so yeah. So if you have boiling point, here you need to put a condition which says that it's the maximum value. So you'll pass in something like boiling equals that value of max, and that will get you the index. That will get you the table where you have the boiling point equal to maximum value. So and that says the index with phi has the maximum boiling point, and all of the others I need. So this is how you're going to get some conditions. Let me quickly show you something else that we could do. So p table, and from the p table, if you want p table of maybe atomic number is greater than 100. So if you put a condition in between where we say from p table, check where p table of atomic number is greater than 100, it should give us the columns where p table atomic number is greater than 100. So you see 100, 108, 103. So this is a way of getting data where a condition is satisfied. So put the data frame and put a condition in between those square brackets, and where that is satisfied, it gives you those values. So over here, boiling point dot max is that. So you get a maximum value. So you see that this is the maximum value. So that's how you're going to do it. So there's another question: can we add DNA? Yeah. So of course you could do this drop any and then just get that column of boiling point. And this. So there are multiple ways of doing drop NA. So, but you can explore some of those, and this is how you get the maximum value. think next time onwards I'll just add this condition thing. But yeah, so you pass in a condition in between and get what you want from there. So get from boiling point, get boiling point where boiling point is max. Could you please share the code? I'm getting some errors. Could you please share the code? Let me see. So this is the first line of the code. So if I do this, it'll be more cleaner version. I'll not need to even open it. Okay. This is the second line, of course. So there we go. This is that, and then any questions so far on this thing what we have done? So saving this data frame. So we have a nice data frame. If you want to save it, what we would do is we get the S block over here in this case. So we get only S block, and there's a method called toCSV, and we say toCSV. We call it S block CSV and index. So if you click on this folder icon that you see here, you'll see that there are some things in here. So there's some sample data and other things, but if you run this command, you'll see a Excel file will be created, a CSV file will be created here, and so you see a CSV file is created, and this CSV file contains only S block data. And I don't know whether we can click on that. Okay, we can click on that. So you see we have the S block data in here at the side. So this is the S block CSV, and this is what people usually do when they are dealing with pandas. So if you have a nice CSV file with data and other things, what we could do is we could directly read that into pandas, and this is how we read it in pandas. So pd.read CSV, and pd is something that is imported on top, and I think it is imported on top, so you can just look at that part of code. It's just, so pd is pandas, so pandas.read CSV, and we are going to read in this S block file and see what it contains, and that's how people usually read in data. I think, okay. So this is how we are going to import pandas. So pandas is the data frame that is the package that we are using as pd. So if we want to call pandas, we'll use a shorthand for it and call it as pd. And pd.read csv is what we are going to do, and then we see the data is in the periodic table format. So this is how people usually read in the data. The Mendeley thing that we started with was just to get some data, but you can use CSV and other data formats to read in data directly into Pandas. So try it out, and if you have any questions, let me know on this. So in the meantime, I have a question here. Could we sort any similar features of different elements? So there are ways of sorting it. So if you want boiling point, let's go with this boiling point right now. So boiling point has NaNs and different values. So if you want to sort this, so you can go ahead and sort it by saying sort values. So there's sort values, and the value that you want to sort is boiling. If you sort this, you'll get a sorted list of values. So it goes from 29 all the way to the highest value of 5,100. So we can sort the elements. And you can sort each or any of those columns. We can even do this on P table. Instead of doing on boiling point, we can do it on periodic table. It does the entire data. And then you see that the thing is arranged now by itself. So the second element is first, then 1, because the boiling point are like that arranged. Okay, so we can do it on the entire periodic table, on the entire data frame, and it gets sorted by something. So if you want to sort by anything, you can sort it. And if you want to do it ascending or descending, so if you just go on this, you see, if you just hover over this thing, you'll see what it needs. It needs by. So by is the axis that we are doing along. So we are doing along boiling point. And ascending is true. So it is now in ascending order. So if we do ascending equals false, we will get the other order that we are looking for. So the highest is 73. The boiling point is this. Okay. So if you hover over this, you'll get to know what it is used for. You'll see some examples where people use it and how it's done. So there's ascending equal to false. You can you can put NaNs in the first position and all those sort of things. So you can look at the documentation here right away. Hope that answers your question. So are there any more questions on this? So this is a basic introduction of how you can manipulate or store data that is in CSV format. Maybe this is the one that you recorded from an experiment. And if you want to find what is the mean, median, and all of that, you can just use describe to get everything, and then even sort it and do stuff. And from that, we are going to see how we are going to plot in the next section of this workshop. So if everyone is comfortable with this, please let me know. We'll proceed to the next session, which is plotting. So any questions on this? Okay, so we shall proceed to the next one where we are going to use it for plotting. We'll be using the same data that we have, but so we'll be using it for plotting stuff. So this is the link. And, so we'll do the same thing here. File, save copy in a drive so that it saves a copy in drive. So there's a question, how to import CSV file from web sources or local computer. So if you have web sources, you can just copy paste in the URL. So if you copy paste in the URL, you will get in the file. If you are using, let me go back to that. Okay, this one. So if you're doing it on a local machine, it's very easy as long as you put in the location to the CSV file, the entire location to the CSV file, it should do it. If you're doing it on Google Colab, what you can do is you can use, you can just drag your file in this place here. If you click on this folder icon here, you can just drag your file in here, and or you can click on this upload button and upload a file onto this and then read it by the name it is called. Hope that answers your question. And there are so many things that read CSV can do, is number of rows and values. There are like a lot of things that can go into it, and you can just hover over this and see what values it needs. And so these are examples and other things which you can look at. So yeah. Okay, so let's get on to plotting, and we'll see how we are going to plot it. And should be very easy to work with now, because we went over pandas and we are going to use that to do this. Just try running this environment again. We are installing Mendeley so as to get the data that we need. And once it is done, start the runtime again. So once you restart the runtime, run this code again so as to have those things imported back. I was using the wrong one. So install it. Once it is installed, it'll ask you to restart runtime. And once you restart runtime, execute the same cell again so that we have imported these things. Okay. So it'll say requirement satisfied, requirement satisfied. So everything is satisfied. So try running the cell twice after restarting the runtime. So you should not get anything in here now. It should be requirement satisfied. Any questions? Yeah. I hope you guys can see my screen in plots. Can everyone see the plot, chemistry plots window open? Yes. So yeah, if you have reached this point, let's go ahead and start with plotting. So the way we we are going to use this pyplot package. Okay. So we are calling import matplotlib.pyplot. So within matplotlib, there's a package called pyplot that we are going to use, and we are going to call it as PLT so that we need not call it by the entire name again. So this is how we are going to do it. We'll call it PLT. Before we proceed, let me just tell you that by the end of this workshop, try to complete this workshop survey so that it'll be helpful in modifying the content of this workshop for the later versions that I'll be providing, and also to get a feedback on what things could be changed or what could be added to it. Okay, so there's a link on top, so you can do it at the end of this or while we are going through it. So back to plotting. There are two ways in which you can plot. One is a sequential way, and the other one is object-oriented way. And we'll discuss both of them, and we'll see how they are different and what we can do with those. So at first, let's get atomic number and atomic radius. So that is what we are going to plot. X would be the atomic radius. X would be the atomic number. Y would be the atomic radius. So there are two ways of getting uh, the data. One is with a dotted notation, just I use like this. The other one, as we discussed before, is with the square brackets. So both of them give us the same data. Okay. So one is the number, and the other is the periodic table. Atomic. Yeah, the first one is the atomic number. The left row, the left column that you see is the index, but this is what we are looking at. So that is the atomic number. We have 118 of those. And next is this, which is the atomic radius. Okay. So we have now atomic number and atomic radius. So now what we are going to do is we are going to plot it. So first with a line plot. So PLT. So PLT again is this PLT. You need to execute run that cell. So PLT dot plot. It needs a X value and a Y value. So X is our number and Y is our radius. So we'll just plot it and we'll see we get a nice plot. So uh, if you guys have reached until this point, if you have any questions, please let me know. If this plot is working, we can proceed with the things, what we can do with this plot now. We'll make it PLT is not defined. Yeah. So if you want that name ever PLT is not defined, you need to run this cell where PLT is called. So run this import PLT as PLT and then try doing it. So you need to run this cell, and then run this cell, PLT. So everyone is getting a nice plot like this. Not a nice one, but it's a decent one. We'll try to modify it and see how we can change the x-axis, y-axis, and color of this, and all those kind of things. So if there are no questions, let's proceed. So if I do the same thing again, I get this. But now let's change color. So if you want to change color, you can pass in another one, which is called color, and pass in any color that you want. So I'll say red. So it'll give us a red color. If I say black, this is black. So instead of some of these standard colorings, you can even use hex codes. So what are hex codes is hex color. So you can use this color picker and see what color you want. Maybe this looks good. So if I want this color, I would use this hex symbol, which starts with a hash. So I can copy paste this into my color thing, and it should give me that color. Okay. So you're not limited by all those standard colors. You can use this hex color thing to change colors, to select whatever you want, and then select the hex code and copy paste it into the color part. And you'll get that color. Okay. Any questions on this part? How to change color? And this is more hands-on, so please try to follow along, because not all of them have the things that we need to do. Okay. So color is what you're going to use to make it colorful. Okay. So what if I don't want a line and I want something else like dash or circles? So what you can do is you can just give some shapes. Like if I want something circular, I would say like this, and it'll give me spheres or circles like this. If I say I want stars or plus like this, so all these will now be pluses. Also, you can change the color if you want. Say color is equal to black. Okay. So these are symbols that you can see, and you can make complex symbols like star. So if you want more of these symbols, you can go to matplotlib. Matplotlib symbols. These are called markers, and there are a lot of those. So whichever ones you want, you just type in this. So if I put in capital D, I'm be getting these diamonds. So let me put in capital D. There you go. Okay. So you go to markers, you'll find a lot of those things, and you can choose any one that you like. And triangle, up triangle, left triangle, lot those. Okay. So number, radius, you can just put in what type of symbol you want, and you can put in color, it will give you that. Any questions on changing the appearance of a line? And if you remove this, if you want to connect it, if you place a dash, it's going to connect all of those. So that is some difference here. So if you put O, it's only going to plot those. But if you even want lines between those markers, you can put a line between those markers. Or you get lines between those markers. Do the other way. Okay. Any questions on this? Okay. So this is changing line appearance. Now let's add X and Y labels. So if you want X and Y labels, that cannot be done in a single line. So you need to say plt dot X label and put in a X label. For X label, this is atomic number, and plt dot Y label, and Y label is radius. And if you do that, you get radius and atomic number. And there are other options for this, like font. You can make font as bold and other things if you want. But if you look at these things, you'll find out how to do that. But I'll not dwell into that part. But you can modify it if you want, like atomic number, atomic radius. We plotted x and uh, X and Y labels. So you'd need to add labels, right? You can even add title if you want. The title is my plot. So I'll put in a title here, which is my plot. How to change the font size or type? So this is a font. There's this font. What is it? Font base, I think. Font is equal to bold. I forgot what it was. So there's this one which is font dict. So font dictionary can hold multiple things, and you are going to put in values in this font dictionary. And let me see. We can do matplotlib. This is how you're going to search. So matplotlib font. You can look for font dictionary. So it'll tell you what all we can do with this. So font dictionary has a family, which family you want it to be. So over here they use serif, the color, the weight of it, the size of it. So if you create a dictionary like this and pass it into it, that is what you are going to get. So let me do it quickly for this one. So font dict is weight, and weight, if I put bold, probably should have something bolded. And if I increase size, 20, these should all be dictionaries. So that is where you see things change. So radius. How can I put a graph inside another graph? So we'll deal with how to play with multiple graphs, but that cannot be done with the sequential method. So right now we are dealing with sequential method where we see things done sequentially. So if you want to add a plot, we'll add a plot. And if you want to add multiple plots, we'll see how we are going to add those multiple plots now. Okay. But for that, we would need to use object-oriented one if you want to put a plot within a plot and do insert images and all of those. But yeah, so this is how you're going to change X, Y labels and add a title. And if you want to font dictionary, you can pass it everywhere. So you can pass it here, and you can pass it even here. And then both X and Y would be font. Okay. So we'll go into the question of dealing with multiple plots. Right now, it's just single plots. Okay. So here you see we did not have any legends added. So if you want to add legends, what we are going to do is we are going to say label is what is this? This is let's call it radius. So if you do this, you will see that there's no change in the plot. But if I do plt.legend and add that, so you'll see that a legend is added. And this is helpful if you have multiple plots plotted in here. Right now we are only plotting one, but if you do it multiple times, so let me do it like this. Radius 2. These would be overlapping, but you will see there are two plots which are overlapping. So radius 1 is one plot. Let me change it. So let radius 1 have only diamonds that we saw, and this one, let it be just a line. So now you see two plots are there in the same thing, and I call them radius 1 and radius 2. So this is what sequential means. We are adding things sequentially into it, and we are plotting legends. So this is how we are going to add legends. So just add a keyword which is label equal to whatever you want, and then a plt.legend, and that will show you the thing that we have with legends. And it's not necessary that you have legends for everything. So if I omit this legend, it will just show one legend. Not necessary that everything needs to have a legend. Any questions on legends? So once you have added legends, let's see how 3 or more. You can add as many as you want here. So it doesn't matter how many plots you add. So all of them will be like that. If you want to put in those Greek symbols, so there are too many radius in here. So if you want to put the Greek symbol, there is something called text thing in here. So matplotlib math text. So math text puts all those expressions and other things in there. So if you want something like this, so you need to use, so you have alpha, beta, and all of them. So you would need to use this math text to put in some values like these into your plot. So you can see all of these acute and symbols. So these are the symbols that you can use. You can use /alpha. Let me use this. Mm, Let me use it here. Hope it works. There you go. No. That would be it. This font dictionary sometimes forgets that. Yeah, so I'm yeah. So if you look at this one, you will see that how things are added into it. So because of this math text, something is creating a problem. But yeah, you can add them with those symbols over here. You can see there's something happening here. But yeah, so that's different feature. So there are multiple ways of adding. This is multiple x-axis, multiple y-axis. So you can do that. If you look at matplotlib, it will show you how to do those specific things. So over here, I'm just showing you how to do very simple ones. And I don't remember at top of my mind how to do multiple axes. But if you can look at this documentation, that's how we need to look at packages. So you can go into examples and then say, okay, I want something like this, and then see how it is done. So we'll deal with some plots like multiple of those, but not filling in them. But this is one of the things that we'll be doing. But yeah, so you can just look at the documentation and just add it what what needs to be added onto it. Okay. So if you want to remove ticks, right? So if you don't want these X and Y values, so there's a way of doing that. It's called X ticks. So ticks are the ones that we put in here. So if you do empty, it will show that the ticks are removed. So ticks is a list of values. So if I put 1, 10 or something, it will show only those ticks. So you can add as many ticks as you want or remove ticks. If I say 1 and 100, I only want 2 ticks, one at 1, the other one at 100. It's going to give me something like this. 1 at 1 and 1 at 50. So you see 1 at 1 and 1 at 50. And if I keep it empty, it removes those ticks. And if I want to remove Y ticks too, I can say Y ticks and Y ticks are empty. It removes those Y ticks. Any questions on this? So this is just removing ticks, adding ticks. And if you want to now save this plot that you have created, so what we could do is plt dot save fig and my plot dot anything, any format you want. And if you are using something like this PNG, you can always use DPI dot per pixels. Is can use a high resolution one like 300 and save it, and you should see that thing popping up here. My plot, you see, and open. Yes, it does, and you see the plot in it. It's a pretty high resolution one. Not going to complain about it. So you can save this picture as a PNG or JPEG or whatever you want. So save fig, and you can of course add in all those things that we discussed, like legends and change colors and whatever you want, and then finally plt.save fig. We're going to save the figure. So in this part, this is the exercise for you, where when you're going to plot van der Waals radius. So you're going to plot van der Waals radius or different van der Waals radius with the same thing. Oh yeah, I just use one radius. Try to use multiple radius and see how they change. And maybe you can even label them so that you can see multiple graphs in here and see how it changes. So try doing this. So you'll be using plot for each one of them, just like I did here. So plot number radius, plot number radius, plot number radius, and you can specify which radii you're using to plot it. So we'll spend a couple of more minutes onto this, and maybe like 5 minutes onto this, because we are almost to the end and we are doing pretty good on time. We have like 15 more minutes to finish this up and we are almost there. So were you guys able to get a plot? If someone can, if someone has done the has been able to get a plot, you can just put it on the Facebook page of Mystery with Code and share it with everyone so that they can see what you have plotted, how it looks. You can just add it as a comment to this this event on Chemistry with Code if you have some nice plots. So while you guys are doing this, let's go with something more easier to work with. Instead of using something like number radius, let's do something more easy to work with, and that's something with the data frame itself. So I have run this, and now if I look at what we have, df radii is all these multiple radius that we have, and we are dropping all na ends. So we say drop na. So we have around, not sure how many we have, but we have some decent number of those. So what we can do with this now is plt.plot, and then instead of saving each column, what we could do is I could use number, atomic number as the x value, and I need a y value here. So let me start with this bondi radii. So I can just call them and just pass in this data is my data frame. So instead of saving all of those, we can just say, this is my X, this is my Y. And where do I get these columns from? Is from this data, which is data frame, which is data.radii. And if you do that, that should give you the same plot as before. So now you can play around with this and say, this is label is equal to names. So this is BO. So one is this, and then we can do multiple of those now. Atomic number, $1 radius. One is Bondi, and let me use UFF. It looks very different. UFF. Let me change some colors. And if I plot this, I get two different graphs. And then if you want the legends, so plt.legends. So you get Bondi and UFF. So this is a way of passing in the data frame itself as an argument instead of saving the things and then passing it on. So any questions on until this part, how we are going to do it with a sequential way? Because we'll now proceed with the object-oriented one. Any questions on this? So let's start with object-oriented one. For object-oriented one, what we need to do is this. We'll call it subplot, and by default it is 1 and 1. So if you look at these arguments that we pass in, is the number of rows and number of columns. So if you see that now, PLOPS. So we create one plot. So if you want to create multiple of those, let's say we need one row but two columns, we are going to do like this. So if we need three columns, it will be something like this now. So that's how we do those plots that we saw here. So each one of them can now be accessed. You can access each one of them and do multiple things. So you can also say 2 rows and 3 columns. You'll see something like this. And within each one, you can keep on plotting whatever you want. So this is the object-oriented way of doing it. So let me just do it for 2 of those. We'll take 2 radii and plot it in one of each of those. So what changes in here is how we are going to do this plt.plot. So we are going to do it on the AX part of it. So AX is a list now. If you look at this, let me just show you what I mean by that. So if you look at AX, so AX is a list. So you see 2 axes here, so 1 and 2. So for each one of them, we have axes. So what we are going to do is ax of 0. So that is just like a list. So we are using this ax of 0 dot plot. Maybe let's do plot. And I can just paste in the same thing that we had used. So if I copy this, paste it here, there you see. So we did it in the first one. If you want to do it in the second one, we are going to do ax of 0 is the first, ax of 1 is that one. So we can do that in the second one. So if at all you had multiple of those, like 2, so in that case, what you need to do is first go with where did that go? So it's a list of a list now. So first will be the rows column, then the columns. So 0th row, the first row and first column would be like this. If you want first, second row, first column. So this is indexing, and then you'll see that plots are done like this. And you can change depending on which row you want to plot. I want to plot first row and second column. It'll go into first row and second column. So this is object oriented way. It's very similar to this, but you have more control on where to plot it. And there are ways in which you can manipulate this to make one a smaller one, the other a bigger one. So you can find more information about that in this matplotlib and subplot. So if you look at subplots, you will have plenty of examples wherein you can do those subplots which you want, like something like this, even of those kinds, whichever ones you like. So you can make one big, one small, and multiple sizes in here. So these are equal sizes, and then can change it to change the alignment and all of it. So there are some keywords that you need to pass in, and that's how you will be looking into that part. And this is a nice way to do it, but there's a nice library which is available, which is called seaborn. So if you use seaborn, it is easier to do things with seaborn too. So if you say scatter plot, it's similar to this thing, but it's sometimes easier to work with. And that's why sometimes we use seaborn, because it gives multiple options to deal with. And it's something like this too. But if you go for seaborn and check out the documentation, it'll show you very, very nice examples that you can deal with. And the coding is not as complex as matplotlib that we used, but we get some pretty plots by just using one line of code. And multiple things can be done with that. So do look out for this as seaborn library, and you can look at the documentation. So yeah, I think this is all the content that I had for today's workshop. If you guys have any question, please let me know. And there's a survey link at the top of this. So please try to fill in the survey. I'll just paste it onto this. And the Colab should be here. Let me see where is it right here. So if you want to link to Colab, the second one is the link to the Colab. The first one is the link to the survey. So please try to fill in that survey. It will be helpful to conduct the further workshops. And we have a couple of more minutes. And if you have any questions, please let me know. And these recordings will be made available online. Let me go ahead and stop the recording.